Welcome to This Explainer. Today, we're tackling an absolutely massive challenge straight from our Day 28 system design prompt. We're going to build a WhatsApp-style chat system completely from scratch. We'll be breaking down exactly what it takes to architect a communication platform that people literally rely on every single millisecond of the day. But before we get into the cool individual features, we really need to wrap our heads around our ultimate constraint here. We aren't building a little app for a 50-person startup. No, we are designing a system capable of handling millions of concurrent users. And that word, concurrent, is the real heavy lifter here. We're talking millions of people typing, sending, and receiving messages at the exact same moment. So here is our roadmap for today. 1. The Million User Challenge. 2. Building real-time connections. 3. Message delivery and storage. 4. Handling groups and media. And 5, scaling to the millions. Section 1, the Million User Challenge. Okay, so every single architectural decision we make from here on out has to answer this one fundamental challenge. How do we support millions of concurrent users without the whole thing just crashing down? If a design choice works great for 1,000 people, but completely breaks at 1,000,000, we throw it out. Simple as that. At this massive scale, you aren't just writing code anymore. You're managing physics, you're fighting network bottlenecks, and you're aiming for absolute flawless efficiency. Section 2, building real-time connections. Now, to let these millions of users talk to each other instantly, we have to move way past traditional HTTP requests. You know, where a client constantly asks the server, hey, got any updates? Got any updates? That is just way too inefficient. Instead, we're going to implement WebSockets. Think of WebSockets as creating a persistent two-way connection between your phone and our servers. They basically act like a wide-open pipe, allowing data to flow back and forth instantly without needing to constantly reload. But maintaining all those open pipes means we have to actively manage the user state. Our design has to instantly track whether a user is actually online, meaning their WebSocket pipe is open, or if they're offline. And knowing the status isn't just about, showing that little green dot on someone's profile. It actually dictates exactly how our server is going to route the very next incoming message. Section 3, message delivery and storage. So message delivery is really a continuous, multi-step journey. Step 1 is send. The message travels right through that open WebSocket we just talked about, straight to our server. Step 2 is route. The system instantly looks up exactly which server the recipient is currently connected to. And step 3 is deliver, where it pushes that message right down to the recipient. When both people are online, this entire sequence literally takes milliseconds. But here's where we hit a real architectural problem. What happens if the person you're texting is, say, deep in a subway tunnel with zero service? The message can't just vanish into thin air while it waits to be delivered, right? Well, this brings us to the crucial requirement of message persistence. We absolutely must design a robust database system that securely grabs and stores those messages the literal second they hit our servers. They just hang out in temporary storage until our system detects that the recipient is finally back online. At that point, boom, the message is delivered and it is immediately wiped from the database. Section 4, handling groups and media. All right, now let's stack on the complexities that modern users just expect these days. First up, notifications. We have to tap right into the device's operating system to alert users even when the app is completely closed. Second is group chat. Now this changes our math entirely because it forces us to broadcast a single message out to hundreds of WebSockets all at the exact same time. And third, media. For this, we actually have to bypass those lightweight text pathways entirely and build separate, heavy-duty storage networks just to handle photos and videos. Section 5, scaling to the millions. Scaling is honestly the true engineering art of handling wild, unpredictable spikes in traffic. Think about it. If some massive global event causes message volume to spike 500% in 10 seconds, our system has to dynamically scale horizontally. That means instantly spinning up brand new server instances and using load balancers to distribute that crazy traffic flawlessly so that no single piece of hardware gets overwhelmed and crashes. You can think of scaling as our invisible force multiplier. It's the magic that ensures that no matter how complex our features get, user number 1,000,000 gets the exact same lightning-fast experience as user number 1. As we wrap up this explainer, just take a second to think about the staggering complexity we just uncovered today, from that ultra-smart routing to massive database scaling. The next time you fire off a quick, funny photo to a group chat, ask yourself, just how many servers had to work in perfect invisible harmony behind the scenes to deliver it in the blink of an